Okay, students, so we can continue. Okay, so last class, I think last online class, we were studying about pressure filters. Okay, we are studying about pressure filter. Uh, so today we'll continue on that. So pressure filter means what? So we have studied about two types of filters in this module. That is, one is slow sand filter, another is rapid sand filters. Okay. Adinu kuda the next filter is pressure filter. Okay. So pressure filter means basically it is there will be a closed vessel and water will be passing through it under pressure. So here the rate of filtration will be very high. It is very like a high amount of water can be filtered in this pressure filter, but the efficiency is very less. Okay, because the efficiency is very less, we cannot suggest it's for the public supplies. It can be used only for some swimming pool cleaning, അല്ലെങ്കിൽ industries, അല്ലെങ്കിൽ individuals like okay. So this is the basic construction. Okay, of this is a pressure filter. So pressure filter is basically of two types. First one is horizontal type, and another is vertical. Okay, as you are seeing, this is a horizontal pressure filter. Okay, and this is a vertical pressure filter. Now, here the working of a pressure filter. So whether it is a pressure filter, whether it is a horizontal pressure filter or if it is a vertical pressure filter, the procedure is same. Okay. So here coagulated but not flocculated water is used and flocculation takes place inside the filter. Okay. So here water after the coagulation will be taken into the chamber. Okay. It might not like flocculation might have not occurred. Okay. Like you know how is coagulation and flocculation occurring. Okay. First coagulation, coagulate add flocculent forming. Okay. So here the water that is coming into the chamber will be after the coagulation and flocculation will be occurring in the filter. Okay, that means once you add the coagulant and you mix it and then you take that water into pressure filter. Okay, so flocculation ഇവിടെ സംഭവിക്കുന്നത് filtration ഉള്ളിലാണ്, sorry, filter ഉള്ളിൽ വെച്ചിട്ടാണ്. Okay, so the flocculation occurs inside the filter. Water enters into the sand bed under pressure and pass to the gravels and reach laterals. From the laterals, it is taken from outside. Okay, so similar to the slow sand filters and rapid sand filters, first water will be entering into the filter bed. Okay, so here water will be, because it is a pressure filter, here water will be entering into the filter bed under pressure. And after that, the pressure water will pass through the sand and gravels and reach the bottom portion. Bottom there will be laterals to collect the filtered water. Okay, bottom there will be laterals to collect the filtered water. Okay, and the filtered water will be collected. Now, how you clean the pressure filter? That is again by backwashing. This similar method that is used in the rapid sand filter, that is backwashing. അടിയിലോട്ട് വെള്ളം കയറ്റി വിട്ടിട്ട്. Okay, from the bottom you will pump water towards upwards and it will take away all the dirt. So similar to rapid sand filters, here cleaning is done by backwashing. Okay. Now if you see the advantages and disadvantages of pressure filters, first one is advantages is that pressure filters is very compact and very easy. Okay, first of all I will show you a demo of a pressure filter. Then we can go to the advantages and disadvantages. Okay, you can see. So this is a video of vertical pressure filter. Okay, so this is how a pressure filter is going to be. Okay, so here you can see the raw water will be pumped into the vessel and it will mixed in the so you can see here. This is the raw water station. Okay, so here first the raw water will be pumped into the vessel and it will be mixed with the compressed air at the top of the filter. Okay, here the compressed air will be mixed with the air. Okay, so that's why pressure will be induced in the water. That means the raw water will be compressed. The raw water will be mixed with the compressed air. But the pressure will be transferred to the water. Okay, so you can see this. See, now the water is passing through the filter bed. Okay, so water is passing to the filter, very filter bed water passing, and finally here we are providing laterals. Okay, here we are providing laterals. Okay, so this okay. Okay, see. Okay, so first raw water and it will be mixed with air compressed air. After that, the presence of the oxygen will promote the physiochemical and the biological removal of the contaminants which generate deposits on the filter grains. Okay, because of the presence of this oxygen, the presence of the oxygen will improve the biological and physiochemical removal of the condens. അതായത് ഈ ബയോഫിസിക്കൽ ആയിട്ടും ബയോളജിക്കലായിട്ടും നമ്മൾ ഈ കണ്ടാമിനൻസിനെ റിമൂവ് ചെയ്യാൻ വേണ്ടിയിട്ട് ഈ ഓക്സിജൻ നമ്മളെ സഹായിക്കും. ഓക്കെ, അതായത് ഈ ബയോഫിസിക്കലായിട്ടും ബയോളജിക്കലായിട്ടും ഈ കണ്ടാമിനൻസിനെ അല്ലെങ്കിൽ ഈ പൊല്യൂട്ടൻസിനെ റിമൂവ് ചെയ്യാൻ വേണ്ടിയിട്ട് ഈ പ്രസൻസ് ഓഫ് ഓക്സിജൻ നമ്മളെ ഹെൽപ്പ് ചെയ്യും. ഓക്കെ, ആൻഡ് ദെൻ ദ എയറേറ്റഡ് വാട്ടർ വിൽ പാസ് evenly to the granular filter bed as a result of several nozzles are placed at the bottom of the filter. അതിനുശേഷം the aerated water. Okay, so aerated water means the water which is having oxygen. This aerated water will be passing through this filter bed, and as the bottom portion you can see there are lot of nozzles are there. Okay, അതിനാണ് നമ്മൾ നേരത്തെ laterals എന്ന് പറഞ്ഞത്. Okay, lot of nozzles are there. Okay, so ഈ nozzles ആയിരിക്കും then water will be passing. Okay, water exists through the nozzle plate and is directed to the consumer. Okay, അതിനുശേഷം water will exit to the nozzles and it will be directed to the consumer. Okay, now during this process a lot of contaminants will be accumulated in the filter bed. Okay, a lot of contaminants will be accumulated in the filter bed. Okay, so how you remove all these contaminants is that is by back washing. That is നമ്മൾ ഇതിലൂടെ first air കടത്തി വിടും. Okay, first you will allow the air to pass through it. Okay, from the bottom you will allow the air to pass through it, and this ഈ air ഒക്കെ ഈ filter bed-നെ ശരിക്കും ഇളക്കും. filter bed-നെ ശരിക്കും agitate ചെയ്യും. അപ്പോൾ അതിൻ്റെ ഉള്ളിലുള്ള ഈ contaminants ഒക്കെ മുകളിലേക്ക് പൊന്താൻ തുടങ്ങും along with the water. Okay, so you can see all the sediments will be collected in the sedimentation tank. Okay, that means from the bottom here you can see an air blower. So this air will be blown into the filter bed. Okay, so that air will agitate all the filter bed, and whatever the particles which is trapped between the filter bed will be agitated. Okay, but in the cooler you will also allow the water to pass through it. So along with the water, all the sedimented particles, all the particles which is trapped between the filter bed will flow upwards, and ഉള്ളിലുള്ള particles എല്ലാം മുകളിലേക്ക് വരും, and it will be collected in the sedimentation tank. So that is pressure filter. That is how the pressure filter is. Now you can see the backwashing. Water അതിനുശേഷം നമ്മൾ പമ്പ് ചെയ്ത് കൊടുക്കും. Okay, so you can see everything is collected in the sedimentation tank. Okay, so this is how. Are you clear with the pressure filters? Okay, so this is how first നമ്മൾ ആദ്യം air blow ചെയ്യും, അതിൻ്റെ കൂടെ തന്നെ you will also allow the water to pass through it. Okay, so here the water pump is there. Okay, so that all the particles will be collected in the sedimentation tank. Okay, so that's about the pressure filter. Okay, so that was the last portion of this module, pressure filter. So not last portion, or portion കൂടി ഉണ്ട്, that is head loss. Okay, that was the last filter in this module. So next one is head loss. So there will be always a head loss in the filter. Okay, there will be always water level തമ്മിൽ ഒരു വ്യത്യാസം ഉണ്ടാവും. So that is called as head loss. Okay, so that head loss is given by this equation, the initial head loss is given by 1.067 V square D CD into psi G n raised to 4 into D. Okay, you have to by heart this equation. Direct problems will be asked. Okay, so HL that is head loss in meters. V is a filtration in velocity. Filtration velocity in meter per second. D is a depth of filter in meters, and psi is a shape factor. D is the diameter of the sand particles in meter. G is acceleration due to gravity in meter per second square. N is porosity. CD is a Newton drag factor. And RE is the Reynolds number. Okay, so direct questions വളരെ സിമ്പിൾ ആയിട്ടുള്ള ക്വസ്റ്റ്യൻസ് ആയിരിക്കും ഈ ഒരു പോർഷനിൽ ചോദിക്കാം. അതായത് ഒരു ഫിൽറ്ററിന്റെ ഹെഡ് ലോസ് കണ്ടുപിടിക്കാൻ വേണ്ടി. അതായത് ഒരു ഫിൽറ്ററിൽ നിങ്ങൾക്കറിയാം സ്വാഭാവികമായിട്ട് 2-3 ചേമ്പർ ഉണ്ട്. അപ്പോൾ ഒരു ചേമ്പറിലുള്ള വെള്ളവും മറ്റൊരു ചേമ്പറിലുള്ള വെള്ളത്തിന്റെ ലെവൽ തമ്മിൽ ഡിഫറൻസ് വരും. ബിക്കോസ് ഓഫ് ദിസ് ഡിഫറൻസ് ദ ഹെഡ് ലോസ് വിൽ ഓക്കർ. ഓക്കെ, ഈ ഹെഡ് ലോസിനെയാണ് നമ്മൾ ഇവിടെ കാൽക്കുലേറ്റ് ചെയ്തത്. ഓക്കെ, രണ്ട് ചേമ്പർ ഇങ്ങനെ ചേമ്പേഴ്സ് തമ്മിലുള്ള വാട്ടർ ലെവലിന്റെ ഡിഫറൻസിനെയാണ് യു കോളിംഗ് ഇറ്റ് ആസ് ഹെഡ് ലോസ്. ഓക്കെ, സോ ഹെഡ് ലോസ് ഇൻ ദ ഫിൽട്ടർ. ചെറിയൊരു പ്രോബ്ലം ചെയ്യാം, വെരി സിമ്പിൾ പ്രോബ്ലം. ഓക്കെ, സോ ഡയറക്റ്റ് ക്വസ്റ്റ്യൻ വിൽ ബി ആസ്ക്ഡ് ഫ്രം ദിസ് പോർഷൻ. സോ ഓൾ ഓഫ് യു പ്ലീസ് റൈറ്റ് ഡൗൺ. ഇന്നലത്തെ പ്രോബ്ലം കംപ്ലീറ്റ് ചെയ്യാൻ വേണ്ടിയിട്ട് ഒരു പേജ് ഒന്ന് വിട്ടേ. ഓക്കെ, ഒരു പേജും കൂടെ നിങ്ങൾ വിട്ടിട്ട് ഈ ഒരു പ്രോബ്ലം എഴുതിയെടുത്തോളൂ. Okay, so determine the head loss of the filter bed of thickness 0.67 meters consisting of sand particles of size 0.4 mm having a specific gravity of 2.65, shape factor 0.85, filtration velocity. The velocity of filtration is 5 meter per hour and porosity is 0.4. Assume the drag factor is 50.92. Okay, all of you please write down this question. So this question what they have asked to find out the head loss in the filter bed. Okay, filter bed head loss kandupidikan vendina paarthullathu. Okay, of thickness 0.67. Okay, filter bed inde thickness aanu 0.67 meters. Okay, and the filter bed is having a sand particles. Avideയുള്ള sand particles ന്റെ size ആണ് 0.4 mm. അതിന്റെ specific gravity 2.65 ആണ്. Shape factor is 0.85 and the velocity of filtration is 5 meter per hour. Porosity is 0.4. Okay, so take the equation. H is equal to 1.67 V square D CD divided by psi G n raised to 4 into D. Equation. So you can directly substitute all the values. Okay, you can directly substitute all the values. 1.067 V means filtration velocity. So filtration velocity ഇവിടെ തന്നിട്ടുള്ള 5 meter per hour. Okay, so നമ്മളത് meter per seconds ലേക്ക് convert ചെയ്യണം. 5 meter per hour you are converting into meter per seconds. Okay, so 5 divided by 60 into 60. Okay, whole square into D. D is diameter of the filter bed. D is the depth and not diameter, depth of the filter bed. Okay, so that is 0.67. So 0.67 CD coefficient of drag 50.92 divided by psi turned into 0.85. Shape factor, this is psi. 0.85 into G. G is 9.81. N is equal to 0.4 തന്നിട്ടുണ്ട് porosity. Okay, N is porosity 0.4 തന്നിട്ടുണ്ട്. So here substitute. Okay. Next is D, diameter of the sand particle. So that also is given 0.4. Okay, so we are taking it. This is given in 0.4 mm. You can convert into meters. Okay, so 0.4 to 10 raised to 3 meters. 0.4 mm ne meter like convert here. Okay, because meter per seconds lana nammal ellathu cheyunnathu. So 0.4 to 10 raised to 3 meters. Substitute it. You will get answer. Are you getting this answer? Please tell me. So direct substitution. Okay. കിട്ടുന്നുണ്ടോ ആൻസർ ഒന്ന് പറഞ്ഞേ. ആർ യു ഗെറ്റിംഗ് ദ ആൻസർ? ഓക്കെ, എത്ര വരുന്നത്? 0.82 meters. അത്ര തന്നെയാണോ കിട്ടുന്നത്? How much is the head loss? 0.82 meters. Okay. ഓക്കെ, അതേപോലെ തന്നെ വേറെ ചെറിയൊരു പ്രോബ്ലം. ബിഫോർ ദാറ്റ് okay, so right now we have studied about the head loss that is occurring in the filtration bed. Okay, filtration bed lalla head loss aanake. Now after the backwashing, filtration we are cleaning it by backwashing. Okay, so once the backwashing is over, the sand bed will expand. Okay, backwashing cheyida shesham sand will expand cheyum. Okay, so because of this expansion there will be a head loss. Okay, അതായത് സാൻഡ് ഒന്ന് വികസിക്കും. ഒരു ബാക്ക് വാഷിംഗ് ചെയ്ത് കഴിഞ്ഞ് കഴിഞ്ഞാൽ ഈ സാൻഡ് പാർട്ടിക്കിൾസ് ഒന്ന് വികസിക്കും. ഓക്കെ, ഈ വികസനം കാരണം there will be head loss. Okay, so that head loss is given by HLE is equal to DE1 minus NE into G minus 1. Okay, and the depth of the sand particles വികസിക്കുമ്പോൾ എന്താ സംഭവിക്കുക? സ്വാഭാവികമായിട്ടും സാൻഡ് ബെഡിന്റെ തിക്നെസ് ഇൻക്രീസ് ചെയ്യും. ഓക്കെ, സാൻഡ് ബെഡിന്റെ തിക്നെസ് ഇൻക്രീസ് ചെയ്യും. ഓക്കെ, അപ്പൊ അങ്ങനെ ഇൻക്രീസ് ആയിട്ടുള്ള അല്ലെങ്കിൽ എക്സ്പാൻഡഡ് ആയിട്ടുള്ള ബെഡിന്റെ depth is given by D is equal to 1 minus N into D divided by 1 minus NE. Okay? So equations just translate only. I will do a problem, then you will understand better. Okay, so we can do this problem now. All of you please write down this question. A sandbed of filter, a sandbed of filter 0.6 meter depth is having a porosity of 0.5 and specific gravity is 2.5 and particle size is 0.6. Expands after backwash to 0.66 meters. Determine the head loss of the expanded sandbed and having a drag factor of 5.05. Okay, so this is a sandbed. So this is how filtration is occurring. See the gravels. This is gravels. So here you will have the sandbed. Okay. So the sandbed is having a thickness of 0.6 meters. The sandbed is having a thickness of 0.6 meters and it is having a porosity of 0.5, specific gravity to 0.5. Okay. Once the backwashing has occurred, the backwashing shesham, the sandbed has expanded. The sand particles expanded. So what happened? The sandbed in the thickness it has increased to 0.6. It has increased to 0.6 now. You have to determine the head loss of the expanded sandbed having a drag factor of 5.05. 5.0. So expanded sandbed in the head loss. Okay. Okay, first of all, write down all the parameters. D depth of sand filter bed. Okay. Depth of that sandbed, that is 0.6 meter. N porosity, G is equal to specific gravity. D is a diameter of sand particles. Okay. Next, D E expanded depth of sand bed. D E expanded bed of sand filter sand bed. CD is coefficient of drag factor 5.02. Okay. First, all the given data are now. Okay. Wait. Okay, have you written all the given data? Now, next, write down this equation, that is expanded bed in the depth in the equation. Okay, expanded bed in the depth in the equation is equal to, that is equal to 1 minus n porosity, 1 minus n divided by 1 minus Ne, that is expanded porosity. Okay, 1 minus Ne expanded porosity into depth of the filter bed. So that is an equation for expanded filter bed. Okay, expanded filter bed in the equation. Okay, expanded filter. First, we sand backwash sand sand bed in the thickness. Okay, but thickness this is DE. This is DE. Okay, this is DE. The expanded bed in the thickness DE. Okay, particular equation 1 minus N divided by 1 minus Ne into D. So 1 by N is equal to porosity. Ne is expanded porosity. D is initial depth of sand bed. Okay. So this equation all parameters DE means how much? 0.66. Okay, DE means 0.66 and N is also known. N is porosity. How much is porosity? 0.5. D is depth of sandbed, that is 0.6 meters. Okay. So ഇവിടെ ഈ ഒരു ഇതാണ് unknown ആയിട്ട് വരുന്നത്. That is you don't know the expanded porosity. Okay. So first of all find out expanded porosity, that is Ne. Okay. Okay. Substitute എല്ലാ values substitute ചെയ്തിട്ട് find out the expanded porosity Ne. So how much you are getting? You will get it as around 0.545. കിട്ടുന്നുണ്ടോ? So first of all find out the expanded porosity. So here equation, this is the equation. So in this equation all the parameters are known. You can write down the expanded, you can find out the expanded porosity now. So how much is expanded porosity? Tell me the answer. .545 something കിട്ടുന്നുണ്ടോ? Okay, 0.545. Okay, so that is the expanded porosity. 0.545 is the expanded porosity. Okay, so now we are having the expanded porosity. Now they have asked to determine the head loss of the expanded sandbed. Okay, so that is the equation. So this is the equation for that. HLE is equal to DE into 1 minus NE into G minus 1. Okay, so here all parameters you can directly substitute and find out the head loss. So D means expanded bed in the depth, that is 0.66. Okay, 1 minus NE, just now we have find out NE, 0.545 expanded porosity. Okay, 0.545. G is specific gravity, 2.65. Okay, so just substitute in this and find out the head loss. So tell me how is the answer? .449, correct. 0.45. Okay, so 0.45. That's the head loss. So 0.45 is the head loss over here. Okay, so very simple problem. Just by heart this equation, you will directly get the answer. Okay. Okay. So that's about this module now. Now we can continue the yesterday's problem. Class later problem now. We can continue with that problem now. They are design of rapids and filters. Okay, here's the problem. This module will be over now. Okay, so we are finding out the area of each lateral, right? Area of each lateral. So yesterday's problem, this is manifold. This is the laterals. Okay, each lateral you are having 5 perforations. 1, 2, 3, 4, 5. 3, 4, 5. 1, 2, 3, 4, 5. Okay, and over lateral and the perforations in it. So yesterday's we were finding out, I think till we have reached till here, area of each lateral. എവിടെ എത്തുന്ന ഫസ്റ്റ് എന്ന് പറയോ? Yesterday till where you have reached? I think area of perforations of each laterals. അവിടെയാണ് നമ്മൾ ഇന്നലെ നിർത്തിയത്. Okay, area of perforations of each laterals. അതായത് ഒരു ലാറ്ററിൽ 5 എണ്ണം ഉള്ളത്. ഈ 5 എണ്ണത്തിൻ്റെയും ടോട്ടൽ ഏരിയ അതാണ് നമ്മളോട് കണ്ടുപിടിക്കാൻ പറ്റുള്ളത്. ഓക്കെ, സോ ഹൗ വിൽ യു ഫൈൻഡ് ഔട്ട് ഏരിയ? ഒരു ലാറ്ററിൽ ഒരു ലാറ്ററിൽ 5 പെർഫറേഷൻസ് ഉള്ളത്. അപ്പോൾ ഈ 5 പെർഫറേഷൻസിൻ്റെയും ടോട്ടൽ ഏരിയ, that is what we are going to find out. Area of perforation in each lateral. Okay, so each lateral is having 5 numbers of perforation. So area of one perforation is how much? Pi by 4 into 0.013 square. Okay, 0.013 is the diameter of the lateral, diameter of the perforations into 5. Okay, so how much you are getting? Tell me fast. എത്ര വരുന്നത്? 5 by 4 into 0.013 square into 5. So how much you are getting? ഞാൻ പറയാം. കിട്ടുന്നുണ്ടോ? അപ്രോക്സിമേറ്റ്ലി 6.6 into 10 raised to minus 4. Okay, 6.63 into 10 raised to minus 4. Very good. 6.63 into 10 raised to minus 4 meter square. Okay, okay. So ഒരു ലാറ്ററിലുള്ള 5 പെർഫറേഷൻസിന്റെ ടോട്ടൽ ഏരിയ ആണ് 6.63 into 10 raised to minus 4 meter square. Okay. Now ഏരിയ ഓഫ് ഈച്ച് ലാറ്ററൽ, അങ്ങനെയാണെങ്കിൽ ഒരു ലാറ്ററലിന്റെ ഏരിയ എന്താണെന്ന് കണ്ടുപിടിക്കേണ്ടത്. ഓക്കെ, സോ ഏരിയ ഓഫ് ഈച്ച് ലാറ്ററൽ is equal to 2 times the perforation area in each lateral. Okay, so area of lateral എന്ന് വെച്ചാൽ ഈ പെർഫറേഷൻ ഏരിയയുടെ 2 ഇരട്ടിയായിരിക്കും ഒരു ലാറ്ററലിന്റെ ഏരിയ. ഓക്കെ, സോ that is equal to 2 into 6.63 into 10 raised to minus 4. So how much you are getting? 6. Area of each lateral is equal to, അതായത് നമ്മളിപ്പോൾ കണ്ടുപിടിക്കാൻ പോകുന്നത് ഒരു ലാറ്ററിന്റെ ഏരിയ ആണ്. ഓക്കെ, so area of each lateral is equal to 6.2 times the perforation area. ഈ perforation area 2 ഇരട്ടിയാണ്. So 2 into 6.63 into 10 raised to minus 4. So how much it is? Tell me fast. 6.63 into 13.26. കിട്ടുന്നില്ലേ? 13.26 into 10 raised to minus 4. Okay, 13.26 into 10 raised to minus 4. അതാണ് ഏരിയ ഓഫ് വൺ ലാറ്ററൽ. ഓക്കെ, നൗ shall I rub this? Okay, next we have known the area of each lateral. Okay, ഒരു ലാറ്ററലിന്റെ ഏരിയ നമുക്കറിയാം. So that is 13.36 into 10 raised to minus 4. Okay, അങ്ങനെയാണെങ്കിൽ can you find out the diameter of the lateral? Okay, that is pi by 4 into d square is equal to 13.36 into 10 raised to minus 4. So from this find out the diameter. How much is the diameter? From this equation, tell me how much is the diameter fast. Tell me, എത്ര വരുന്നേ? 4.1 centimeter. കിട്ടുന്നില്ലേ? So you will get this as 0.041. Okay. Centimeters convert D is equal to 4.1 centimeters. Okay. So diameter of each lateral. So the lateral diameter is 4.1 centimeters. Okay. So you can write down the note like this. We can use 80 numbers of laterals. Okay. So you can use 80 number of laterals with the dia as 4.1 centimeter and at a spacing of 15 centimeter. Okay, and each having five perforations of 13 mm dia. Okay, with a 45 centimeter dia manifold. കിട്ടുന്നുണ്ടോ? Okay, like this. This is 40 centimeter. This is not 45 centimeter. Ours is 50 centimeter manifold. Okay, the 50 centimeter manifold in the laterals under. Okay, this is laterals, and this lateral is having a diameter of 4.1 centimeter. Okay, and this is having a perforations, 5 perforations. And in this perforation, the diameter is 13 mm. Okay, perforations, and the spacing between these laterals is 15 centimeter. Spacing between these laterals is 15 centimeter. Okay, so that's about the under drainage system. That's about the under drainage system. Here is a small portion over there. Okay, so now that's all about the under drainage system. So we have designed the under drainage system. Now the last one is you have to design the wash water trough. Okay, you have to design the wash water trough. We have to design the wash water trough. Wash water trough each okay. So we are assuming that wash water trough is placed at a distance of 1.1 meters. Okay, 1.1 meters wash water trough space assume. Okay, number of troughs is equal to width of the filter divided by spacing. Okay, so number of width of the filter divided by spacing. Width of 4 divided by 1.1. How much you are getting? Tell me. 4 divided by 1.1. That will be around 3.63 meters. Okay, that is 3.63 meters. Okay, so we can say approximately 4 numbers of troughs. Approximately you are providing 4 numbers of troughs. Okay, next one is wash water discharge. How much is the discharge? So wash water discharge അതായത് എത്രത്തോളം വെള്ളമാണ് അവിടെ വരുന്നത് എന്നുള്ളത്. So wash water discharge is equal to rate of washing into area of filter. Rate of washing into area of filter. So how much are you getting? So rate of washing, you don't know rate of washing. So rate of washing, you can assume it as 60 centimeter per minute. Okay, you can assume the rate of washing as 60 centimeter. So tell me how much is the water? എത്രത്തോളം വെള്ളം അവിടെ വരും എന്ന് അറിയുന്നത്. So tell me the answer, please. Why no one is responding? Okay, I think it's better to take in the next class because ആരും ഒന്നും പറയുന്നില്ല. I thought next class fresh module start ചെയ്യാന്ന് വിചാരിച്ചതാ. ഈ മോഡ്യൂളിൽ കുറച്ചും കൂടെ ഉള്ളൂ, കുറച്ച് ഇതൊന്ന് തീർത്ത് കഴിഞ്ഞാൽ നെക്സ്റ്റ് മോഡ്യൂൾ വി കൻ സ്റ്റാർട്ട് ഫ്രഷ് മോഡ്യൂൾ ആയിട്ട് തുടങ്ങാമെന്ന് വിചാരിച്ചായിരുന്നു. But no one is responding.